So, today we're going to see the most asked feature for any third-person shooter series I did, and that is actually camera collision. Okay, specifically when we're either going through the floor, going through walls, going through narrow areas, okay, and basically stuff like that. Now, this one is going to be very simple. We're going to cover what you can do. Okay, this will be my approach. We're going to talk how it's done and what you should also look out for. So, before we see the script, I'm going to pause this and I'm going to go into the scene view. So basically this is how we say there is camera collision. We can actually control how many steps we have over here. Okay, as you can guess, depending on your target platform, this will change and you have to set it up or come up with something better. But this will work in most cases and in most third-person controllers. Okay, so what this does is basically takes an increment. This is the maximum point the camera can go, and based on the step by step, basically we see what's around the camera, and if it finds an obstacle, then that means we're going to cut the distance between each two by 2. So if this hits an obstacle, it's going to get half the distance, otherwise half the distance or half the distance. You can set it up to into 1/3 or 2/3. It's entirely up to you. Okay, just keep in mind of that. Let's see it in action too. So as you can guess, something hit, probably this one, so it brings it on half the distance. Okay, it's as simple as that. If you worry about performance, let's check it with a profiler. Yeah, okay, let's check the spikes. Even on the spikes, you can see obviously there is the physics processing, which is only about 1 millisecond. Okay, I don't think it's that much, especially we have so many raycasts. If you think that all the stuff we have, 1 millisecond is it's not really a problem. Okay, obviously you can create a fewer raycasts and all that, so you do not even need this much. This is just for the example. So let's go to the script, and the one script we're going to work with is basically camera manager. And in the camera manager, if you remember, we have fixed positions, which basically what it does, it places the target pivot position or the actual pivot based on what we have saved on our active states. Okay, and if it's depending on our actual active state we have, then it sets up first the pivot and then it fixes the local position of the camera transform. Now we're going to take only the Z because our camera should only move on the pivot only on the Z, on the local Z specifically, and we're going to encapsulate this behavior which we're going to call camera collision. Now, camera collision, okay, we need to pass the target Z and the actual Z, we're going to call it like that. It's going to be a reference variable, so it means if it changes in this function, it's also going to change outside of this one. Now, step is our actual step, which is basically our maximum distance. It's going to get the absolute value of our target Z. The step count will be how many, basically a resolution plus 1. So for example, if we have 0 over here, then it means it's going to run at least one time. So the step incremental is how many times we are actually going, the percentage we are moving based on a step. The way we find this is we're doing step by step count. Okay, we subdivide by step count. Obviously, if you have 0 over here, then you will have a problem over here. Now, we're going to do a simple for loop. We're going to do first a raycast that's going to look towards if there is any obstacles from, it's basically the blue line, and it's going to look if there is any obstacle from the pivot point of where the pivot is towards the maximum position of the camera. Okay, the first thing we're going to look is this one. Then, and we can actually encapsulate this inside this, now that I save this. Yeah, let's take it from here and let's drop it over here. Oops, that's too much. Let's make sure everything is correct. It looks like it's correct. Let's also bring this back. Let's fix this also. Okay, so basically it will only do this once and then it's going to do everything it needs to do. Now, we're doing the raycast. Okay, nothing special. We have our origin, which is our pivot position. The direction will be the negative of our pivot forward, and that's why we only basically take it as the absolute value, so that we can control the direction based on this and not on what we have on our target Z. We're throwing a debug draw array, of course. We're doing the raycast. Ignore layers. Okay, it's on start. Put it over here on start. We're ignoring the third layer, which is the Unity default ignore layer, and then the ignore raycast layer, and the layer which is for the controller colliders and stuff like that. Okay, we can only ignore this. If you want to ignore props, other stuff, you can also add it. Okay, it depends what you want to do. Now we have if we hit something, if that one hit an obstacle, basically we get the distance, and what we're simply going to do is take the half. If you want 1/3 or 2/3 or whatever you want over here, okay, just change the subdivision. And we also, because this is going to be applied as local position, we know that it needs to be negative, so we simply make it to the negative. Okay, now if it doesn't hit something, then that means there is either no obstacles from over here. However, it doesn't look if the camera is close to any obstacles. So the problem with this, if we're doing it only this way, if the camera is almost touching the ground, or in a case like this, let's rotate it like this. Okay, you can see that there is going to be a lot more threshold for this, especially for cases like this. However, if it almost touches the ground, in a case like this, okay, it might actually start, not actually start clipping, but it might have, yeah, on the next frame that is going to be within an obstacle, you're going to see a few weird shapes. Okay, so, and that is because we do not know what's basically next to the camera. And the way we're fixing that is If this doesn't hit something, then we're going to do another for loop for 4 directions. If you want to add more, you can. I don't see why though. It looks like it just works exactly as it's supposed to. So we're going to do a for loop. We have a for loop. We have our step count. We have +1, and you'll see why we have the +1, because if we do not, then that means we're basically leaving the one we actually need the most, which is the final one. So that means we actually need the +1. Okay, so we're going to do a for loop like this. Our direction is going to start at 0. Second origin we need is our original origin, which is the pivot position, plus the direction we're having towards where we're looking, that is, multiply by the step, multiply by the step incremental. So on the third step, it means you're going to move 3 times with this incremental. Okay, if you only want one, then you can simply do it like this. If you only want to remove the for loop, not the for loop, this for loop, okay, so you only have one step, then you can simply find the origin, the direction, multiply by the step, and it will always be doing this on the position of the actual camera. And I should have closed this, but anyway. Okay, it will always be doing this over here. That might or might not be a problem, depending on what you want to do. Okay. And for example, if it hits something over here, it's still going to clamp it, but it won't know if we are actually, if the camera is over here and it's hitting on an obstacle, then it will not know, it won't know it. Okay, so what you can do is then do another raycast. If this doesn't hit, another for loop basically, and if it does hit, and the other for loop will have the origin whatever the camera Z is, and if it doesn't hit, then simply leave the camera where it is or go back. It's simple as that. And yeah, the reason why though I don't want to touch anything on the camera is because the camera is very variable, its position, so you might have something very uncontrollably, especially because the camera position is updating on every frame, so that means it's not that reliable. Now, okay, for the for loop we're going to do 4 directions depending on the eye, and we're going to start right or left, up, okay, and we're throwing a debug draw a raycast, and we can actually do a break over here. So if any of these raycast hits, then it's going to break the whole for loop, and or we can just return. Yeah, so yeah, it's going to return, so it's going to end if it hits something. Now after this, then it's simply a matter of just changing, instead of getting the target Z, just change this so it gets the actual Z. Let's test it, make sure we have no problems, and it doesn't seem we have any problems. And you can see that because it hits something, then that means that it's not going to do any of the other raycasts because there is no need. Okay, and similarly the behavior is still almost pretty much the same. Let me actually, I want to do a lock cursor on this. so that I can control it a little bit better. Let's jump. Okay, obviously you might get into positions that have a few problems, but as you can see, if you're also moving the camera a little bit slower, then you have no problems. Okay, the other stuff you can do is basically if it's at a position like this, then you can simply hard code the camera, so it's always going to rest on a predetermined position. Okay, but I don't think you need it. And if it's hugging a wall, obviously this might not be something ideal. So what we can do, and another thing we can actually see is that we can basically ignore the very first one, the very first step. Okay, and the way to do that is simply going into our actual script, camera collision, and instead of starting from 0, then we can simply start from 1, and if we hit play, you can see that boom. Okay, we ignore that. Obviously 4 it might be too much. Let's do a 2, so we're only doing 3 raycasts and 2 raycasts since we skipped the first one. Okay, and you can pretty much set this up to whatever resolution you want, but I think, yeah, even with 2 you're probably going to have something that is actually you can work with. Okay, so for example, a case like this, I think it works just fine. For small cases like this, it also works just fine. Okay, so depending on the steps, if you are having it at half distance of each step, then that means that that way how many steps you have will control on how close your camera can be on your character. Okay, so I think I'm going to end the video for this one. It wasn't something much, it's just something that everyone was requesting. You can see that it's only a matter of just infusing functions at this point, and you can simply add and change so many different behaviors. Okay, there can be other ways you can do this, but I think we just found one that works. We didn't have to change a lot of stuff into our script, which also works just fine. I've seen other ways, can't say I really care for any other way, to be honest. Okay, there's other ways that they add a collider on the camera, which I don't know why. And what you can also do with this is, if you are hitting something with this, you know the position where you're hit it from, so what you can do is add an offset to our turn angle. Let me find. Okay, we have an offset over here, for example. So let's see if we hit something over here. Let's see if we say offset x will be direction.x and offset y will be direction.y. So this, I don't know if it's actually going to readjust the camera. Let's see. Yeah, it's not really ideal because it's way too much. However, what we can do is do a by 5. I'm going to lock the cursor. Okay, you will see a small jump into the camera. It's not done by me, it's done by the offset we put on our code. Okay, yeah, I don't really particularly like it. Let's see if we can only use it from cases like this. And yeah, ignore the profiler. Okay, you can put a little bit of an offset. It's not really, as I said, ideal. Let's try one. Although the direction, it's normalized. So yeah, this is way too extreme at this point though. But anyway, it's fun. Anyway, okay, if you want to add an offset, of course you can do something else over here. But since you have the direction you are finding an obstacle from, then that means you can actually put, you can put movement to the camera towards the opposite direction, which that will make, and yeah, which in turn is going to make you also move the camera too. But I think just this way work just fine. Now, okay, we're going to end with this one. We've covered what I wanted to cover, so we'll see what we're going to add and keep adding on this one. Now, you know what to do. Like, subscribe, and if you also feel that this helped you and you want to support my work, then do so on Patreon or on Gumroad, where you can get a project or two, so the profiler can stop annoying me by running out of frames. Okay, so I'll see you next time.